Welcome everybody to the 9th lecture of Informatik 1. Today we will talk about the internet. If we would be in the lecture hall, I would show you this YouTube video which covers the history of the internet in a very nice way. And since we are doing this lecture online this year, I will put the link to this YouTube video again in the video description of this video and you can also find it again in the Teach Center. So assuming again that you have already watched the video, let's reiterate some of the contents, or let's pick up some of the contents of the video. So imagine that you have a MacBook on the left hand side and the Windows computer on the right hand side, and the goal is that we want that both of these computers communicate with each other, and in order to do so, those two computers need a standardized conceptual model for communication. So both of these computers need to implement a shared conceptual model for communication. In other words, they need to speak the same language, right? And therefore, the goal is to enable the interoperability of diverse communication systems. So each system, what we have, should be able to communicate with each other. And therefore, the OSI model was developed. And OSI stands for Open Systems Interconnection. Here you can see how the OSI model is implemented, or how the OSI model looks like. It consists of 7 layers, and each layer has a specific purpose. The first layer is called the physical layer, and it basically transforms the binary signal consisting of zeros and ones into a physical signal. And the physical signal could be, for example, the current in a cable, so der Strom in einem Kabel, or the radio waves over a wireless LAN, and vice versa. So it is responsible for transforming the binary signal into a physical one, and also the physical signal into a binary signal. And then the next layer is the data link layer. It controls how or when the data is placed and received from the same media. It's like talking. So in order to understand everything, no one should speak when I am talking. And I should not talk when you are asking a question, for example, because we share the same media, for example, the lecture hall. And yeah, so this is the second layer. It is responsible for reliable transmission of the data between nodes. And then the third layer is the network layer. And the network layer is routing data packets to the right destination, which could be a sender or receiver. And it does so by looking at the IP address of the package. And the network layer then decides where to send the data. Basically routing data packets. And then the fourth layer is called the transport layer, and the transport layer divides the data into smaller chunks or segments, and it also performs congestion avoidance. So for example, if the PC or the computer sends data in 100 megabits per second, and the smartphone can only receive at 10 megabits per second, then the smartphone tells the computer to slow down. So this is congestion avoidance. So to recap, the transport layer is responsible for the segmentation of the data into smaller chunks. It also performs congestion avoidance and error control. Then the next layer, the fifth one, is the session layer, and it helps for setting up and managing the sessions or connections and also performs authentication and authorization. So what you should remember is that the session layer is responsible for managing the sessions and connections. Then the next layer is called the presentation layer, and it translates the data into machine readable data and also performs compression and encryption. So basically it transforms the zeros and ones into machine readable data. And then the last layer is called the application layer, and it is used by network applications, for example, like Chrome or Firefox or an email program. And it also implements all those protocols like HTTP, SMTP, POP3, and so on. So the last layer, the application layer, is basically used by services and applications. So we now know how the actual raw signal, which is coming from the Ethernet cable or the wireless LAN signal, is translated into actual information, which is displayed on the screen, for example, like an email. So we now know how this process works inside the computer using the OSI model. And the next question, what we need to answer is how we can find the computer in the network. So how can we send this information to another computer? And to do so, we need another protocol, namely the Internet Protocol, or in short IP. And therefore, each computer has an IP address, so which is just a numerical label which is assigned to each device in the network. We have two versions of this IP protocol. The first being the IPv4, which consists of 4 times 8-bit blocks. So it consists of 4 8-bit blocks. And if we do the math, we get 32 bits. And such an IP address can look as follows. So for example, 127.0.0.1 or 129.27.200.1. So each byte is separated with a dot. Or in other words, each 8-bit block is separated with a dot. So 8-bit is equal to 1 byte. And yeah, you see that such an 8-bit block is not represented in binary, but in the normal decimal number system. So you see here decimal numbers. So 127, for example, is a decimal number. And since one such 8-bit block only consists of 8-bit, we can only store numbers from 0 to 255. So the maximum number which you can store with 8-bit is 255. And in total, since we have 32 bits available, we can address in total, or we can assign in total 2 to the power of 32 labels. So which means we can address about 4 billion devices using this version of the Internet Protocol. And since back in the days, the developers thought that we wouldn't reach 4 billion devices as soon. They thought it was enough, 32 bits. However, the current days we have already much more than 4 billion devices in the internet. Therefore, we needed a new protocol which was able to address more than 4 billion devices. And therefore, IPv6 was introduced, which consists of 8 16-bit blocks. And again, if we do the math, 8 times 16, we get 128 bits. And such an IPv6 address looks like follows. So You see here that it is encoded in hexadecimal, because you see in this example address down there we have the characters D or B or A. So it's encoded in hexadecimal, unlike the IPv4, which is encoded in decimal. So you have hexadecimal letters here. So for example, 2001 colon 0db8 colon 000 colon 0042 and so on. So you see each 16-bit block is separated with a colon, and as already said, it's written in hexadecimal. Alright, and since we have 128 bits available, we can address 2 to the power of 128 devices, which is quite a lot. So it's 3.4 times 10 to the power of 38 devices. And yeah, I think this protocol should be, we can address enough devices in the next few years with this protocol. So let's move on to the actual web, so the World Wide Web. So in the years 1989 and 1990, Tim Berners-Lee presented the World Wide Web, which is nowadays known as the www. And the idea behind it was to share documents over the internet via unique links or URLs, and then to link to other documents content through hyperlinks. And therefore the hypertext transfer protocol was invented. And maybe you already saw this when you're entering a website in the web browser. You often type http colon / www. and so on. So this means that the website or the resource or the document which you are accessing on the internet or on the web is accessed by the hypertext transfer protocol, or using the hypertext transfer protocol. And then this led to the release of the very first web browser and the web server in the 1990s. So how does this HTTP protocol work? So HTTP works as a request and response protocol between a client and a server. So your PC, for example, on the left hand side, your laptop is the client, which has a web browser running, and another PC somewhere in another country, for example, or at the Google data center, is a server. So it's another PC, a server, which is hosting a website. And then your client, your web browser, is requesting a resource. It's a request, and it sends this request to the server, and then the server returns a response to the client. In this case, a response to the web browser. So it is a request-response protocol. And for example, such a server could also be a computer at TU Graz. And if we ping the TU Graz server, we get the IP address 129.27.2.244, which is hosting the TU Graz website. And again, we can request the TU Graz website by sending a GET request. So this means get the index.php file from the website, and then the TU Graz server returns the file content of the requested resource. With that said, let's look at an example using Python again. And in order to access the HTTP functionality in Python, we can use the requests module, which enables us to send GET requests, for example. So yeah, first we need to import the requests module, and then we can call the GET method inside the requests module, which basically performs a GET request and returns me the resource or the file which is located at the specified URL. In this case, I specify the TU Graz URL, and I want the contents of the index.php file. So I request the index.php file at the TU Graz server. And I do this by using a GET request. And if we execute this, we store the result in a variable which is called response_tu. And then we can print out, for example, the result of the GET request. And we do so by accessing the text property of the returned object, and we just print out the first 150 characters of this response. And if we execute this, you see here that the response is such strange characters, and these characters here represents an HTML file. As you can see here, it's an HTML file with HTML tags. So for those of you who are familiar with HTML, may have noticed that. So we can verify this if we open the web browser and go to theograz.at. So this is the main page here. And if we make a right click and look at the quelltext, the source code, quelltext is not an English word. If we look at the source code, you can see here that we successfully printed out the source code of the website. So this is the file which is basically telling the web browser how to render the web page, or which images should be displayed, which text should be on the website. And in this .php file, all this information is contained. And as you can see here, this is the same text as we printed out here. So we successfully retrieved a resource from the internet using the request module and performing a GET request. Alright, so we can also send a GET request to other resources, not only to PHP files, so we can get any kind of resources or files. So for example, if we look at the Zentralanstalt für Meteorologie und Geodynamik in Austria, which is basically a website which contains a lot of weather data in Austria. They have a file, a CSV file, which contains the weather data, the daily weather data in Austria. We can also send a request to this CSV file, a GET request, which then returns the content of the file. So in this case, we store the response of this GET request in a variable called response_temp. And then again, at the next line, we print out the text property of this object. And the text property in this case holds the content of the file, same as before. And as you can see here, this is a normal CSV file as we already know it, where the first line is the header of the CSV file, describing the columns. And here you see the delimiter, which is in this case a semicolon. And you also see here that the strings are escaped with those quotes here. And we have also already learned that we can use, for example, the pandas package to also read CSV files in a more convenient way. So here I've imported the pandas module, and again I specified the same file, the same resource on the internet at the servers of the Zentralanstalt für Meteorologie und Geodynamik. And again we can specify the separation character, it's the delimiter. And if we execute this, we have again in the background sent a GET request to the server, and then using the pandas module or the pandas package, it automatically parsed the CSV file for us. And if we execute this line here, we get the contents of the CSV file in a nice format, which is in this case a pandas data frame. And yeah, you see here it automatically parsed all the header automatically and splitted the values using the specified delimiter here. And we can look at Graz, for example, here. So here you can see an entry of Graz, and the time is 5 p.m. and you see here that it had let's see, minus 1.5 degrees in temperature, for example. And then using pandas again, for example, using the locate, we can filter out, for example, only the row which contains the data for Graz. Yeah, using the syntax which I have shown you already in a previous lecture where we learned about pandas. Again, here I want only the row where the name is equal to Graz, and the second entry here I state that I want all columns. So here, using this notation, I filtered out only the columns, only the rows which contain or where the name of the column is equal to Graz Flughafen. That's it for today's lecture. As always, thank you for your attention and see you next time.